Graph representation. An overview.
Graphs are mathematical structures used to model pairwise relationships between objects. In computer science, graphs can represent networks, connections, and pathways. Two common ways to store a graph in code are the adjacency matrix and the adjacency list. Each approach has unique advantages and trade-offs that make them suitable for different applications and scenarios.
What is an adjacency matrix?
An adjacency matrix uses a two-dimensional array to represent a graph. Each row and column corresponds to a node, and a cell contains a value indicating whether a direct connection exists. For unweighted graphs, a value might be 1 for a connection and 0 for no connection. This method allows quick lookups, but can use significant space for large graphs.
What is an adjacency list?
An adjacency list represents a graph with an array or list for each node. Each entry contains a list of neighboring nodes it connects to. This method is generally more space efficient, especially for sparse graphs with few connections compared to the total possible. It makes it easy to access all neighbors of a node, but may be slower for checking for a specific edge.
Pros and cons adjacency matrix.
Advantages: fast edge lookup. Checking if two nodes are connected takes constant time. Simple to implement. Disadvantages: consumes O(n)² space, even if the graph has few edges, making it inefficient for large, sparse graphs. Adding or removing edges is straightforward, but iterating over neighbors is slower compared to an adjacency list.
Pros and cons adjacency list.
Advantages: uses less memory for sparse graphs, as it only stores existing edges. Iterating over all neighbors of a node is quick. Disadvantages: edge lookup can be slower, as you may need to search through a node's neighbors. Implementation can be more complex, especially for weighted or directed graphs.
Choosing the right representation.
The best representation depends on your needs. Use an adjacency matrix when graphs are dense or you need constant time edge checks. Choose an adjacency list for large, sparse graphs where memory efficiency matters and fast neighbor access is more important than quick edge checking. Understanding each method's strengths helps you write efficient code for different graph problems.